Hi everybody. In this lesson we want to look at how we solve quadratic inequalities. Now you should remember that when we solve a quadratic equation like this, we have to do it very differently from the way we solve a linear equation like this. In a linear equation you can just sort of get x all by itself on one side and shuffle everything else to the other side, right? I'd subtract 1 and divide by 2. But when I have a quadratic equation, I have to get 0 on one side and then factor it and set the factors equal to 0. All right? Well, in the same way, when we solve a quadratic inequality like this, we do it very differently than when we solve a linear inequality like this here. So, for example, if I have x squared greater than or equal to 4, probably the most common wrong way to solve this is students would think to just, well, how about if I just take the square root of both sides and say x is greater than or equal to 2. And you'll notice if you do plug in numbers greater than or equal to 2 like 3, it does work, and you might think that works. But you should also notice that if you plug in a number like minus 3, now minus 3 isn't greater than or equal to 2, but minus 3 squared is greater than or equal to 4. And so then you might think, well, oh, I forgot the plus or minus. Well, if I write x is greater than or equal to plus or minus, will that work? What does it even mean that x would be greater than or equal to plus or minus 2? On a number line, that means I'd have numbers here at negative 2 and here at positive 2. And if I want the x is greater than or equal to positive 2, that'd be these, right? And the x is greater than or equal to negative 2 would be these. So what would that even mean? And notice that if I plug in like 0, 0 squared isn't greater than or equal to 4. So this is just completely wrong. I can't solve a quadratic inequality that way. To illustrate how we do solve them, I'm going to start off first by solving it graphically. So one thing I could do is just graph y equals x squared. Now we know that's a parabola. If you square 0, you get 0. If you square plus or minus 1, you get 1. If you square plus or minus 2, you get 4. So here's this parabola that looks like this. Okay. And I would like to know, where is that x squared, that's the y equals x squared, where is that greater than or equal to 4? So if I were to graph just y equals 4, that would be this. And so graphically, this is saying, where is my blue parabola on top of, bigger than, greater than, or touching, equal to the red 4? And you can see that that's going to be for these x values down here. All right? If I have any x's that are less than or equal to negative 2 or greater than or equal to plus 2, that's going to make my parabola, right? It's this part of the parabola up here is greater than or equal to the 4, and that corresponds to these x's down here. At x equals negative 2, the blue parabola equals the red 4. At x equals positive 2, the same. And then if I have any x's over here, then I'm going to be greater than, the x squared is going to be greater than the 4. All right, so my answer to this problem, that should make sense just in terms of the plugging numbers in, is anything in the interval from minus infinity to minus 2 union from 2 to infinity. All right, so if I plug in, like, say, negative 3 squared is 9, that's greater than or equal to 4, or negative 4 squared is 16, that's greater than or equal to 4. Even if I plugged in negative 2.1 squared is going to be bigger than 4. If I plug in negative 2, it does work. That gives me 4, which is greater than or equal to 4. But if I plug in anything in between these, right, in this interval, you can see graphically that the x squared is not going to be as big as the 4. If I plug in negative 1, I'll just get 1, and 1 isn't greater than or equal to 4. But then again over here, as soon as I get up to 2 again, 2 squared is greater than or equal to 4, 3 squared, and so on. So this is my answer. So now what we want to do is understand how we can solve that same problem algebraically. And ultimately, the algebraic method is really just trying to figure out what the graph is or understand what's happening graphically without actually having to graph it. Okay? So to solve this algebraically, what I want to do is first of all get 0 on one side, just like we did when we were solving quadratic equations. Okay, so I'd get x squared minus 4 greater than or equal to 0, and then go ahead and factor that just like we did. Okay, and once you have it factored, the zeros, the x-intercepts, where the values of x that make this equal to 0, are going to be called critical points. So x equals 2 and x equals negative 2 that are solutions of the quadratic equation. We're going to call those critical points, and you'll notice that those points divide the number line into 3 intervals. All right, so if I plot these points right here, here's negative 2 and here's positive 2, and that gives me an interval from minus infinity to minus 2, and another interval from minus 2 to 2, and another interval from 2 to infinity. And you'll notice that those intervals correspond exactly up here to where I have from minus infinity to minus 2, that's part of the solution, and then I have this interval from minus 2 to 2, that's not part of the solution, and then over here from 2 to infinity. All right? So another thing you could think of is if I take this graph and I subtract 4, I'm going to just bring everything down on the x-axis, and I'm really just looking where the graph of x squared minus 4, where is that going to be greater than or equal to 0? All right. What I do then is I'm going to get use a test value from each interval. So let me scroll down here a little further. I have this down here as well, so I'll just write that again. So I got the interval from minus infinity to minus 2, and minus 2 to 2, and 2 to infinity. And I'm going to choose a test point out of this interval, and I'll just choose like negative 3. Choose as simple as one as you need, but you can't choose the end point of the interval, negative 2. In this interval, I'd choose 0. That's really easy. And if I, out of this interval, let's choose 3. Okay? All right, so then what I'm going to do is I'm going to take that test point, and I'm going to plug it into my expression right here. So here's what I plug it into. And if I plug negative 3 in there, negative 3 squared minus 4, you'll notice that's 9 minus 4 is 5. Okay? And that means graphically that if I were to come over here at negative 3, then the graph is going to be up here. And in particular, the graph is going to be greater than or equal to 0. Okay? So that's going to satisfy the equation. It's going to be true in that interval. If I plug in 0, 0 squared minus 4 is negative 4. Okay, so I plug in 0, I get negative 4. And negative 4 isn't greater than or equal to 0. That's false. If I plug in 3, 3 squared minus 4 is 5, and 5 is greater than or equal to 0. That's true. All right, so again, if I plug in 0, I'm down here. If I plug in 3, I'm up here. And of course, I know that's the graph, right? The graph, I know, comes down here, and it's going to cross at these points right here. It's going to go below the x-axis, and then it's going to come back up and go up like that. All right, so really it's just all we're doing here is trying to determine what the graph looks like without necessarily entirely graphing the equation. All right, so the answer is going to be those intervals where the inequality is satisfied. So notice in this interval I plugged in negative 5, I got something positive. In this interval I got something negative, and in this interval I got something positive. Now I want to know, where is it greater than or equal to 0? Well, greater than or equal to 0 means that it has to be positive. So I know it's going to be in this interval right here. Your solution is going to be the minus infinity to minus 2. Any number in this interval is going to make it positive, which is greater than or equal to 0. And likewise, anything in this interval is going to make it positive. All right? So then another thing we could do is we could verify our answer by graphing that inequality on our graphing calculator. So if I go to my graphing calculator here, and let's plug in x squared minus 4, And let's graph this on my standard setting here. Okay, so just from that graph, if you know that, you can look at this and say, where is x squared minus 4 greater than or equal to 0? Well, it's greater than or equal to 0 here, which corresponds to these x values to the left of negative 2. And it's greater than or equal to 0 here, that corresponds to these x values to the right of 2. So this is the exact counterpart of the graph that we had up here originally, and we just move that graph down onto the x-axis by subtracting 4 from both sides. All right. Now, something else you can do with your calculator, instead of graphing just y equals x squared minus 4, you can graph y equals x squared minus 4 is greater than or equal to 0. You can actually graph the inequality you're trying to solve. Now, there's a greater than or equal to symbol under the test menu right above the math button here, so hit second and then test, and then number 4 is a greater than or equal to. Now we call that a relational operator, and what it does is it tests if x squared minus 4 is greater than or equal to 0, and if it is greater than or equal to 0, then it's going to return the number 1. So this is actually going to graph the number 1 wherever this is true. And if the x squared minus 4 is not greater than or equal to 0, if it's false, it'll graph the number 0. So now when I hit the graph button, you'll notice it graphs the number 1 here from minus infinity up to negative 2, and then again over here from 2 to infinity. But notice that it doesn't tell you if it includes the point 2, and you're not entirely sure if it's, negative 2.1 or exactly negative 2. So this is more just a way to roughly check your answer. It's not going to be a cure-all and always tell you the exact solution like you need to get when you solve it algebraically.